Okay, so I don't know if you were in the jury before, but what we like doing is providing solutions for deorbiting and for propulsion. In this challenge, I'm going to focus on this plasma brake deorbiting. This is something we want to be category leader in the industry, and we have one development starting. All right. So what's the challenge really? It's all these tightening legislations which are coming, also providing plasma brake solutions for launcher and for larger space shuttles and mission allow to have more space. And of course, also having longer satellite missions. So how do we actually provide a solution here? So either deorbiting all broken small satellites. We see here on the right, I will focus only on the benefits. It's about maintaining infrastructure and space for a longer time. As well as deorbiting user launcher rocket. So at this moment, Aurora is getting a lot of requests from launcher companies to develop theater technology with them. And the reason being is really the capability to deorbit 500K size on satellites with a very, very light and a small technology. So plasma brake is very, very light, and we can apply it for this type of deorbiting. So how does it look like? As I said before, it's about really, with very light material, being able to move a couple of 100 kilos. And these are the type of systems, the tower systems of our technology. We are on simulating phase and testing that with some relevant players in the industry. And that's our journey. So this is our team. Our team is a mix of scientific people, engineering, and micromechanics. And we are on a process of fundraising for bringing this solution commercial in 2 years. That's all. Thank you. I don't come again. Promise. Excuse me.
And our next company is Celestial.
Thank you. Okay. Hi. Thank you for having us here. Hi. My name is Mayank, and are our slides up there? Okay. No. The slides. Okay, I will just start. I'm one of the founders of Celestial, and thank you. Okay, we are working on small satellite applications. Actually, there are a lot of problems with small satellites. They are very small, and this limits their power generation capabilities, their volumes, and all kind of things makes their lifetime very shorter. And we want to solve this problem. And we think the solution lies in multiple integrated systems who are robust and who are even compatible enough to adapt to the changes that are coming into missions, especially with small satellites. And this is why we want to take advantage of the hardware. This is why we designed such antennas who have 3 times the advantage and gain performance to any other antennas. So they don't take more power in, but gives more strength to the link and give more power to the satellite communications and link margins. And on this topic, actually, we have already compared our antennas, and these are the performance, but I wouldn't go into there because today it's a special day for us to actually launch our own innovative product, which is this antenna. And I just want to focus on that much. Okay. It's just not working with me. Okay, so this is a solar power integrated antenna, and why we are designing this? This is where I want to focus on. The thing is, now there are multiple mega constellations coming up. Satellites will have multiple antennas on different directions now, and you will have to face, and satellite developers will have to face enormous challenge to balance out these antennas in different directions, or balance out these solar panels to maintain power budgets or to maintain link margins. And the problem, and this is my personal feeling, I think the problem with space industry right now is they're trying to perfect the system, which I believe should not be there on the satellite at all. I think we should start removing systems from satellite, and we should perfect systems in such a way that our needs are met and have lesser and lesser systems on the satellite. And this is one of the steps we at Celestial are trying to take. We are trying to merge the system so that we have one less system to put on board of our satellite, and we are able to perform multiple systems and multiple objectives with one system. And the result is solar panel integrated antenna. The first step of this antenna was this. It's very hard. A normal PCB, just you will find in the industry, but this is offering 3 times the performance. So we perfected the design first. No innovation here, but then moving forward, we are now innovating. This is transparent material. Good for space applications because we will use radiation coatings and other things, but also we are adapting to never used manufacturing techniques for space applications, which could be test results now, but could also be something that we use for lunar economy or lunar missions to do 3D additive manufacturings in space in situ. So this is something that we can already test now. And as a result, now this would be something that would look like this in the future. This is just to show that we have something in our mind that we are developing, but this is something we are going to reach. And this is the first step of this, actually, because the second step, when we have perfected this design and this is already working in space, we would already move to our second phase of development where we will start designing these antennas on deployable solar panels. So now imagine a satellite having a solar panel which is deployed outside, having X-band, X-band, S-band and KU band antennas all on board, which means there is no antenna on the body of the satellite. You can use 10 cameras, or you can use how many redundant satellite primary payloads, and all your link margin and link budget and all your satellite communication needs are moved to the deployable solar panels, which means a satellite which is small enough with lower power budget will have very good link because it has so many antennas and can communicate from larger distance with the same power. So for example, doing moon mission with CubeSats or with smaller satellite is possible with that way. Secondly, we can have these kind of antennas onto a satellite which is to communicate in multiple directions. So inter-satellite links are there. So this kind of antennas, which will have solar panels with them, can actually maintain the power budget, but then can also give you link capacity and link margins in multiple directions. So there are so many advantages that come along with this. And we are trying to push this really hard so that we can have right now with this antenna that I showed you to do some LEO missions and demonstrate this technology, but then move to mega constellations, and then ultimately to lunar economy and deep space missions. So this is the team that is working behind this idea. It's me and my colleague Johannes. We are doing our first space mission this summer with the antenna that I showed you, the classical antenna. And this is the team that has been working on this, and we do everything in our house, from designing to selecting the material, but most of the things we outsource, trying to do some kind of smart manufacturing. Please reach out to us if you find our project interesting. We are at booth 08 over here. Thank you very much.
And ESA.
C'est ok. Pour cliquer, je vise où? C'est là. Ah, c'est vous qui cliquez? Ah, le reste il est là. Ok, parce que parfois ça marche pas très. Si je vois que ça passe pas, c'est moi. Ok, ça marche. Hi everyone, I'm Bora. Thanks for being here. We're going to talk about data. Yes. So we're ESA, and our product is Apalgo, and we make sensor data, time series data usable. So yes, data is everywhere. This is not a secret for anyone, and that's also the case in space and with satellites. And a satellite can generate a lot of data, and some of those data are time series data, like here you can see, data that evolve in time. And the problem we see as a data scientist and data analyst is that we spend 90% of our time in navigating, understanding, and labeling that data. This is something we have to do, and this is something that is really complex. So when the problem with sensor data is that today sensor data are not really readable. If I show this to an expert, even an expert in the domain, and ask him what this means, the expert will probably tell me that he has no idea, he has to dig more into it. So what we're trying to do is, we're trying to bring a search bar where a user can search for some events, and we're trying to make it appear onto the graph, the events that the user are searching for. So now, actually the graph is legible. Like now it's readable. Now we can understand what happened, and this helps a lot the search for patterns, search for events, and resolution of problems. So how do we do it? So the way we do it is we do it in 3 steps. First, we have a tool called Candidate Generator. It's an AI event detection system which will propose some event candidates to the user and will highlight them in a gray bar. After that, the user will come back on the tool and with a simple UI with some buttons, label 4 to 5 events, and then we have a label propagation algorithm that will find the patterns of that event, and through the entire data set of our client, will label and propose new labels of those events. That will help labeling all the data of the clients and also bring up the data quality. So what is Apalgo? So we are actually an augmented analytics, as would say Gartner, for sensor data, for time series data, where we unlock the labeling and search capabilities for our clients. And data insights are actually very critical for our clients, from anomaly detection in a monovariate or multivariate environment, to data labeling, to pattern recognition. Yes, so thank you very much. Just the next one. Thank you very much. So I'm Bora. If you need to reach me, this is my contact info, and we're just there. And yes, this is me, but 10 years ago. Somebody asked me the question just before. Thanks.
Ouais, là, ouais. And our next candidate is Grasp.
Okay.
And it's the right one to change the slides. Yeah.
Hello. Up, that. Hello, good afternoon. I'm David Fuertes, CEO of Grass Global. First of all, thank you very much for the opportunity to pitch here. It's an honor for us to have this opportunity. Okay. So we provide services in the field of the Earth observation. We are doing remote sensing, and what we are doing is focus on the atmospheric product, and once that we have a good atmospheric characterization, we can also have a good product of the underlying surface. The data that we are working on, it's of the interest of the air quality, air pollution monitoring, climate change, and any other application related to the surface applications. The name of GRASP stands from generalized retrieval of atmosphere and surface properties, which is a powerful algorithm that allows to retrieve remote sensing of observation from very different sources, from ground and space. We have already applied our algorithm for several official missions from large space agencies for the operational products from ESA, EUMETSAT, NASA, and many other large space agencies around the world. One of the most important things of GRASP is that it allows, sorry, I'm not sure if it's me who is passing the... One of the important things of GRASP is that it's able to retrieve the data from the different sources and even makes them. So it's satellite, ground, or even both of them together. About the company, we was born in 2015 as a spin-off of the University of Lille with the main goal of add extra value to the code that I have already presented, but now we have much more skills than before. Now we are also developing hardware by ourselves. We are developing air quality instruments for ground, and also we are developing our own satellite payloads. This I will explain you a bit later. The company is around 30 people with high scientific profile, and we have a strong impact in the scientific community, and every year we have new publications. So these days we are working on this satellite mission. It's called GapMap. What we are doing is develop our own multi-angular polarimeter that is called GapMap. The idea is to have a constellation of tens of them for characterization of the atmosphere. We have already participated in the HARP mission, which was awarded as the best CubeSat mission of the year 2020. So we have already the experience on this, and we have already the fundings for this mission that the first IOD demonstration will be done at the end of this year. So the goal of these multi-angular polarimetric measurements is to monitor air pollution. There is no any other multi-angular parameter flying right now, and several will be planned for the next year from EU and US, but currently there is no public data from this sector, and we understand that the number of applications and the potential market is huge. So basically this kind of measurements has 2 orders of magnitude more information than any other measurements, remote sensing measurements that we can find, because they are calibrated, they are multi-angular, and they have polarization. And the potential applications are, for example, aerosol monitoring, for the atmospheric characterization that can be used for any large space agency for the characterization of their spatial missions, air quality, that is of the interest of the pollutant industry to know their impact on the environment, or for policymakers to know what are the best decisions for their citizens, but also any application related to the surface. So we can do the atmospheric correction for the big private constellation of high-resolution data, and also any application that require scientific level of surface products, so precision agriculture or ocean monitoring. So what we are offering is what we call air science, full air science product chain. We manufacture our own payload. We process our data, we generate level 1, level 2, and level 3 with the algorithm that I have already explained, GRASP, and now we are working also in modeler simulations. What we are doing is use chemical transport models for generating our own forecasting of aerosols, of air quality, and also for the identification of sources of emission, of pollution. So our mission is try to help to face the coming challenges that are there in this green transition economy, and providing air quality, high quality data for air quality, for surface monitoring, and for climate change. So thank you very much for your attention, and if this is of your interest, we are happy to receive you in our booth. Thank you.
And our next company is Vioma.
Thank you very much. So, good afternoon, everyone. Until my slides are being found, I want to just start with a little thought experiment. Imagine you're on the German Autobahn, you're traveling at 7,000 meters per second, and you close your eyes. So that's pretty much what satellite operators are doing today. They are flying in space at very high velocities, and they don't even see the majority of objects that could collide with them, simply because there is no information available about those objects. And this is what we want to change. So welcome to Vioma, the operating system of space. We are keeping space safe through real-time, space-based satellite monitoring. I'm Stefan, I'm the CEO, and I'm going to walk you through this presentation now. Today we heavily rely on space-based services. If you had a croissant this morning, probably the farmer that was making the wheat for that croissant was relying on space-based services. So all of us are pretty much always relying directly or indirectly on space-based services, which support a $10 trillion downstream economy. However, as I said, space is not well observed. There are a lot of objects out there that we simply don't track on a regular basis, so we don't even see if they are a danger for our satellites. And we are generating more and more objects that are too small to be seen, and we are actually on a point where there is no return and space might become a no-go zone. We want to solve this problem by observing these objects and provide this information in real time. How do we do that? How do we see those very small objects that are still very dangerous for your satellite? We do this by launching our own telescopes into space. Now with these telescopes, we can even see the faintest object. So for each object that is being tracked today on a regular basis, we are going to see an additional 10 objects. So we increase space safety by an order of magnitude. With our satellite-to-satellite communication system, we can download this information directly and provide it to our customers. But we're not only providing information on where the objects are, we're also providing the software on what to do with this information. So with our smart algorithms, we process all those data points, we build a catalog, we tell you when there is something incoming, and we propose the best course of action in real time. Now on the left on this dashboard, you can see information on an upcoming conjunction, what is the danger, the probability of collision, and on the right already the pre-calculated optimal maneuver to avoid this incoming conjunction. So you can simply upload this to your spacecraft and you're done with it. So we're not only providing information on all the objects, we're also providing space safety software as a service. So where are we right now? We have the mission analysis phase 0 and phase A done for our satellites. We have a unique payload which has been designed for space to observe space objects, ready for integration. We're currently procuring the parts. We have already the prototypes of our smart astrodynamics algorithms ready. And this is really the hardest part, the data association. And this is where we are the strongest. We are 6 PhDs in astrodynamics, and this is really our core competency. But we don't have to wait until we have our own satellites in space. We don't have to wait until we can observe the small objects, because already today we are providing an on-demand space object tracking service. And this we can do because we have access to a network of networks of ground-based observatories. So we are bringing in together all the different networks, and we're making sure that it's a unified interface for simple tasking of observations. And for this, we have already onboarded our first pilot customers. One of them we're turning into a paying customer right now. And it will also be this dashboard where we add additional services for satellite operators and so on. Why us? What makes us special? I already said the hardest part is actually data association, and this is where we are strongest because we're 6 PhDs in astrodynamics. Furthermore, we have also a small team around our space segment, which is for mission planning, spacecraft design, satellite operations, and image processing. So we are not only providing services to satellite operators, we are actually satellite operators ourselves, so we really do know what are their needs. Last year, we raised a 2 million euros seed round, and now we're looking for Series A round. So yeah, thank you very much for your attention, and please help us in keeping space safe for future generations. Thank you. Thank you.
Klebsiella. I'll get, yep. Yep. Vioma. Klebsiella. Wait. It's for you. I can never pronounce it. It's
No problem. Clepsydra is.
Klebsiella. There we go.
problem, it's okay.
Thanks.
Good afternoon, everyone. My name is Angelo Guillino, Business Development Manager at Clepsydra. And what we offer from Clepsydra, as I said before, is time. Let me explain this in more detail, and I hope you can understand this after my presentation. When we created our company, we identified that all edge computing sectors or embedded systems, whatever you want to call them, share a common limitation, which is a common challenge, which is data processing limitation for real-time applications. Currently, there are two approaches to face this problem. We can upgrade the hardware, but this is costly, and it is not always available for the user, of course, for space applications. We can use cloud solution, but it is also costly, and it has other limitations like long latencies and, of course, cybersecurity issues. So none of them solve exactly the problem. So what does Clepsydra offer? Clepsydra offer a third approach with using just software. So by the use of very advanced and powerful techniques, we have been capable of developing software solutions which increase data processing in real time with zero data loss and a reduction in the power consumption of the processor. When we say that we offer time, I mean exactly this. We can offer to the user to increase the performance of their application immediately with non-integration effort and on the same hardware. We have two products commercially available, both of them. Our core product is our SDK. We can use it for general data processing. We are agnostic to the type of data, so we can process data coming from any kind of sensors, LiDARs, camera, and so on. We can use our SDK to increase the performance of heavy algorithms like encryption, data compression, and also virtual reality. We have a second product, which is what is called in the AI world the inference engine solution. So we can take any kind of machine learning algorithms and run it more efficiently for edge devices. This is a benchmark that we have for our SDK. The idea here is to show you that we can process 4 times more data with a reduction up to 50% on the power consumption, compared with current data processing techniques. As I said, this is just by the use of software, no extra hardware, and no cloud computing. Some use cases related to image processing for space applications, data recording for aerospace applications, and we have started a new project for encryption to increase the performance of encryption algorithms. This is a demo that we have available for our AI solution. You don't see it properly in the screen, but the idea here is to show that we can process double amount of data with half of the CPU consumption compared with main market leaders, which are TensorFlow and OpenCV. As I said, we offer the inference engine solution, but not only that, we can provide with different AI algorithms in different fields, like computer vision, vision navigation, and also object detection. Finally, this is an integration example of our solutions. We can combine our two products for different AI, for different applications. For example, for Earth observation, we can process images coming from a camera on a satellite with our SDK more efficiently. send these images to an algorithm that can be object detection, for example, with our AI solution. So in a nutshell, Clepsydra can increase the performance of real-time applications immediately with non-integration effort and on the same hardware. That's all. This is something to highlight. We closed our seed investment round last December of around 1 million Swiss francs. We have started our some projects and pilots with big players in the space sector, and currently we are more focused on commercial action like lead generation, partnership, and so on. This is our team. On behalf of our team and myself, thank you very much for this opportunity.
Plasma bound. Where is it? No, Xavier's disappeared. Okay, let's go to the next one. Prometheus. Wait, because I can't find. Wait, on fait Prometheus.
Have the preparation, presentation, we have it.
Right.
Okay, great. Ladies and gentlemen, the best way to write history is by creating it. And the best way to deal with environmental disaster is by preventing them. This is what Prometheus does. And ladies and gentlemen, I'm Eleftherios Plafountzis. I'm the founder of Prometheus Space Technologies. And in 5 minutes, I will present you how we will benefit humankind and we will change the world. The problem, ladies and gentlemen, is that our planet is in flames. The huge problem that provides the best solution globally is the wildfire devastating effects in human life, in the environment, in infrastructure, in society, and the economy. We saw the problem firsthand last summer, while thousands of homes and businesses were destroyed. We face an unspoken disaster. For more than 1.5 million hectares of valuable forest totally burned, while more than 6,450 megatons of carbon dioxide emissions generated from wildfire caused direct and indirect death on more than 33,000 people. Current methods are slow, expensive, and complicated and cannot provide the vital solutions that they need. What if, ladies and gentlemen, could actually prevent the worst from happening? We need to revolutionize how people respond to this crisis, and not just small incremental improvements. We need an entirely new approach. And this Prometheus comes for the rescue, ladies and gentlemen. With our pioneering Hercules rapid and resilient crisis response mission, we provide an advanced space product for rapid response capability that will provide humanity a new layer of protection against cosmic danger with unparalleled speed, agility, effectiveness, resilience at a global scale. Our Hercules R2 CRM receives high-resolution satellite data by an advantageous process of artificial intelligence, deep learning, and advanced GIS provide groundbreaking solutions. Our model that created from our great partners at Quiron Digital and developed from our GIS specialists provide an accurate 7 days wildfire prevention forecast in 10 meter spatial resolution. With the help of artificial intelligence, we have achieved success rate greater than 19%, and we improve the resolution up to 800 times. We are able to provide the exact location of any imminent threat in GPS accuracy 1 week in advance. Ladies and gentlemen, we are different because we are aerospace engineer veterans, and we are dedicated to cover all the needs of our end users in prevention, preparation, and response with cutting-edge and game-changing technologies, because we provide an accurate picture of the future 1 week before any incident occurs, because we provide so high resolution that could tell us about individual trees in forests, because we provide the exact location in 10 meters by 10 meters accuracy. Ladies and gentlemen, I'm standing before you because we are dedicated to change the world and benefit humankind, and we need all the support that we can get. Because we are more than space startup, we are environmental pioneers that paint a picture of the future with incredible detail. Because we may mitigate climate change effects, because we're reducing CO2 emissions, because we're saving human lives, because we protect the environment, because we protect our planet from generations yet unborn. We are what the world needs on the bad days, but yet we are more than this. We're working hard in the present to create a future without bad days. Ladies and gentlemen, we are Prometheus Space Technologies, and we create the future. Thank you.
And Ride.
Hello everyone, I am Valentin, CEO and founder of Ride, and today we're gonna talk about access to space and launch as a service. But before, let's play again a quick riddle. So what's the common point between train, truck, plane and rockets? So they all are made for transportation of goods or people. Now a little bit harder. What's the main difference? So let's see it with a different angle. So they all have done their digital transformation, and they can be booked online through a data-oriented, safe, and convenient digital platform. Well, all, not really. But that time is over with Ride, the digital platform empowering launch as a service. So Ride is, in a nutshell, is a new way to approach the launch process for both launch operators and satellite operators in a more deal-oriented, convenient, and direct way. So in other words, now satellite operators can book online a launch, compare and match with the capacity, and secure the launch service agreement. The why and the raison d'être of Ride is mainly to enable the new golden age of space. And I mean, you all have seen these figures. We are expecting 10 times more satellites to be launched. There is like 200 plus launch vehicle projects all around the world. And clearly, small sat launch is becoming a commodity. However, for everyone right now, it's still a long, costly, and very complex process to launch. So it's a time now to embrace a real network competitive economy. And on Ride, it's not only about launch vehicle. Of course, this is a key milestone of the process. But it's also about OTV capacity, deployers and integration provider, as well as the insurers and regulators. They can now plug their data about their service and products. They can also manage the inbound leads within the platform, and at the end conclude some agreement in a clear framework. On the other side of the platform, on the demand side, whatever you are, a private constellation, an academic operator, or a mission provider, you have your place on Ride, and you can easily match with the proper launch solution and get access real-time to their data. So our core innovation is all about our AI model and the matching algorithm that allow instant matching and a clear compatibility ratio between all the actors of the value chain. But it's not only about the launch search, it's also about the launch planning. Because finding the right solution is one thing, but then implementing and delivering the requirement is another thing. So clearly, we add a second step on the platform, which is the launch management software, where our team, our tech, and our contract allow clearly to manage all the process to launch. And I would like to insist on the last point, the contract. This is our second core innovation. We design a very simpler contract for launch that clearly balance the responsibility to everyone and allow the small actors to get a more streamlined and better contract relationship with land provider. So, for the past year, we have experienced the platform with more than 100 providers and operators, and we clearly saw patterns of benefits, mainly 20 to 30% of saving on launch, due to avoidance of middlemen, due to guidance on the process, and a real competitive environment. And the second aspect is also a clear value on the platform is we have shortened of 2 months the lead time for launching, mainly due to easy access to information and avoidance of endless back and forth with the provider. On the other side, the value are also the way to acquire new clients, and in addition of gaining market share, it's also about improving the profitability, mainly for a streamlined relationship and the avoidance of all the customer acquisition costs that we take on us. So it's now real. We are live. We're a 10-people company based in France, incubated at ESA. And you can find all these actors on the platform and basically your launch on the platform. So it's a unique opportunity for Europe to lead for real a platform business worldwide. And I thank you very much for your attention. You have just here a quick view of the platform, and we are at Boost CU21 today and at ESA tomorrow. Thank you very much.
C'est bon, on est down. Voilà. And our next company is Share My Space. And c'est le droit, the right.
Okay. Merci beaucoup. Yes.
Okay, perfect. So, good evening, everyone. My name is Benjamin Etard. I'm head of sales at Share My Space, and we are a space situational awareness company based here in Paris. We are 13 persons. So I know you have already been introduced on the problem of space debris. What we do is space surveillance from the ground. So why is it important at the moment is because our orbits are occupied by an increasing number of satellites. We can't trust anymore the number because we always hear in the news new constellation going up in the sky. And what is happening is that in the last 15 years, there's been an increasing number of space debris accumulating in the orbits with only a few events. A missile on Chinese satellites, on their own satellites. It's also a big collision in 2009 between a Russian satellite and an American satellite. And the next event was actually last year in 2021. There was another collision which had up 1,800 new debris. And obviously we also saw the news with the ESA from Russia that brought it to the problem. So the thing is, these are only the debris we can track, and we believe that we can only track 3% of everything which is in orbit. So why only 3%? The thing is, at the moment, we rely on radars mostly and telescopes. That's right. Yeah. Okay, and so this 3% accounts for the numbers that the US catalog from the US Army is giving us about 30, a little bit more than 30,000 debris. We believe there is 1 million below this critical size of 10 centimeters, and it could be hundreds of million, about 1 millimeters. The problem is the impact is huge on your satellite. It's the speed of 40 times the bullet of the rifle. And at the moment, the CNES, for instance, receive alerts every day, 5,000 alerts at the CNES. There is about 2 maneuvers, maybe 4 sometimes per satellite per year. And if we compare to aerospace, the safety is about 10% of budget as provision. So that's a real problem, and currently we are limited because we don't know what's happening in space. Because the technology we use, mostly radar, come from the army, from the US military. They are not cost efficient, they have a lot of energy consumption, and we don't have the resource to map the world with radars and also telescopes. If we use the current technologies, it's a real problem for us to scale the space object detection. So that's what we do at Charmway Space. We want to provide turnkey and independent solution for space surveillance. So how we do it? Okay, so we do it with a new kind of telescopes optical station. So let's see if I can send the video. All right. Okay, so what's new with this technology? It's a concept of operation that enables, for the first time with optics, the 360 degrees scanning of the sky with these telescopes. So you can automate it completely the way you can track what's happening in the sky. It also works in LEO. Usually we use telescopes for GEO. By improving not only the concept of operation, but the mirror as well, we're going to be able to get lower than the 10 centimeters. And it's also a lot less energy and cost as an investment. So this is why we can plan a fast development as a network. We already have 2 station prototypes in France, and we're going to quickly increase the number of stations across the world. So with only 6 stations, we can go way beyond what the US catalog can offer in terms of number of objects we can track. So just to give you an example of what we can do today with our station, here you have an example of an object smaller than 1U. Here is an example of a docking, just here that you can see with the strike lights. And this is an example of relative navigation in GEO. And if you look on the left of the picture, there is a weird object that is rotating, and we can know it because there is the luminosity that is changing, and can track it with telescopes. Sorry, it's a little bit slow to... Yeah, it's better? Okay. So this is the luminosity that we can track, so for the attitude. Okay, so we don't only produce our own data, but we also integrate all the value chain to provide end-user services. So I'll go quite quick on them. We have a SaaS solution for collision avoidance, which is completely ready at the moment. I'm going to show you how it looks if I manage to use the remote here. Okay. So this is a spot from Friday, and you see all the red spots are alerts, dangerous alerts on a random fleet of satellites. You can see Sentinel, for instance, receive a lot of alerts at the moment. The risk is real, and this is why we automate the avoidance maneuver to provide some credible scenarios for avoidance. We also do some automated maneuver detection. We won a challenge for NATO not so long ago, and we use AI to improve the characterization of maneuver. Obviously, this interests the military, not only the satellite operators, and we target both markets, institutional and commercial. So the traction is good. We already have some customer, private and institution. What is key is that there are some countries that want independent solution for SSA, and we can provide it to them. This is why we are supported by some investors. We did a seed round in 21 with 1 million. We're also supported by the European Commission with a 2 million grant, and we are currently on the Series A. So to conclude this speech, a little perspective with Europe. 2 weeks ago, there was an announcement from the European Commission that says that collision avoidance will be mandatory if you want to operate with European institutions. And this won't be possible if the Europe doesn't have the data. And so it might be a little bit difficult to cover the world with a traditional solution. So Europe really needs our help to build an independent and sovereign European space catalog. Thank you very much.
Oh, je sais. On a tous réussi aujourd'hui avec ça.
Ah ouais?
Ouais. Alors, là, c'est comme ça. Stratosiste.
Merci.
Le micro là. Hein.
C'est le dernier?
C'est le dernier?
Non, c'est l'avant-dernier.
Encore un.
Is it on now? Perfect. Okay, then once again, good evening, ladies and gentlemen. Bonsoir. I already had this presentation 1 hour ago, so I will not want to bore you again with the same talk. Although the presentation is the same, I will try to focus on different points. It's working now. Perfect. As I mentioned before, we were working on it for 5 years. What I would like to add is that we really try to focus on other fields like legislation as well, because in the past, nobody was able to operate in the stratosphere, so nobody took care about it. So we are trying now, together with our colleagues from other companies, create together the concept of operations and legislation for stratosphere so that everybody can operate there safely in a cooperative environment. These are our 3 platforms. Really, the Stratoscout, it's aimed to test, for example, images for space in a stratospheric environment, compare the data that you can get from the orbit with the data that you have in stratosphere. We already have many offers and are planning missions in Azores to do this testing for many companies that usually already have images on ISS and other satellites. So it's on our plan. Nevertheless, the main platform remains the Skyrider. As I mentioned before, it's high-altitude pseudo-satellite, it's lighter than air, filled with helium. For the future, we presume it will need to be hydrogen as the helium is really running out in the Earth. The altitude will go from 18 kilometers to 23, also depending on the latitude. We know that the missions with current design can last definitely 6 months, but from the data Loon had, we know that the balloons were also able to last for almost a year or even longer. So there is definitely a potential to have longer missions than just 6 months. What is our benefit is that we have lots of energy from the solar panels, so we can provide up to 5 kilowatts directly to the payload, which is pretty a lot in this industry. We talked a lot today about the space debris and how many satellites we have on the orbit. This is the future of the satellite industry. High-altitude pseudo-satellites do not pollute the orbit, and they provide almost the same services as satellites. We can provide the payload back because we are able to land with it, really. There is no more pollution on the orbit. Everything will simply launch up to the sky and then land again, keeping it clean, keeping it open for everybody. Of course, compared to drones, it's perhaps a bit more costly, but still it's got longer duration, and for some local operation, it still makes sense to use hubs compared to drones. Regarding the applications, really, the main focus is Earth observation, and I know that ESA is really active in this field as well. We've been trying to cooperate in some fields in the future, so there are discussions open on this. I already talked to your colleagues from ESA that there may be a possibility of cooperation for the Sentinel-2 data comparison, so we are looking on that in the future as well. Really, the market is there. We know it. It's needed. There is lots of money on the table. It's just really that we need to make all the things work, especially get the concept of operations working together with the rest of the industry, and then we just set off. What we feel that is really benefit of our platform is that it's lighter than air. Once you have aircraft, it simply falls. During the winter, the night is longer than the day. You cannot get enough energy from the solar panels, and the aircraft simply falls down to the jet stream, can get damaged, gets off the position. Really, I do not feel that the future is in the aircrafts, it's the airships. What Stratobus and Sky do, they really build huge airships with different applications used, really go for the small niche of small payloads, 10 kilograms around. That's the future as we see it. Also, as we are really small platform compared to stratospheric sizes, it's really easy to handle this platform. It's not so big, you don't need the infrastructure, it's just an empty field. You can take 3 containers. In one you have operation center, in second one you have all the materials, in the third one you have the launching crane. You can do it anywhere without any required infrastructure. You don't need airports, anything like that. And you can land it also anywhere in the world and kind of put it together again. Yeah, these are the unique selling proposition. I already mentioned them before. It's the container solution. It's really universal. You can hang up anything on the platform, and it doesn't necessarily need to look only downward. Actually, the original idea was to use it as an astronomical observatory. If you have a telescope on top of it, you already have all the full spectrum, also infrared, so you can do the initial scanning for the scientists, and then once you know where you want to look at, just simply direct the big satellite on the spot and get the real data. This is really accessibility for all the scientists all over the world, that they can really get the look at the sky for really affordable solution and in the reasonable time. They just say us and we put it there. These are the milestones. We've been part of ESA community for some time as a member of the ESA Business Incubation Center. We are still in touch. It's been great cooperation. We filed the ESA grant application to finalize the Skyrider project. We are expecting results in the few days, hopefully. If it was approved or not. So we'll see how that goes. Anyway, we aim to really scale it up, to looking for global operations, because, as I mentioned, it's really the future, and it's missing there. It's missing in the infrastructure. It's a key point. Even if you use the satellite still, you can direct it, for example, for communication, you have strong link. If you can just send it through the stratosphere, resend the data in a full quality through Storm, it still gets full operation. And there you can see the structure. It was really kicked off by InKind and especially by ESA BIC in the beginning, for which we are thankful that we could have it to really kick it off. Then we had to work on the projects, on the customers. That was our task. And finally, we were able to really kick it off and hopefully setting up to successful future. And if there is anybody from the investment side, really there is the time if you want to jump in and share the success with us. We are currently in the Series A looking for €6 million to really kick off the commercial operations, co-found the projects, finalize the development, and we are willing to offer 10% of shares. And there is almost a certainty that this will pay off in the future. So again, thanks a lot, everybody. Merci beaucoup pour votre attention. And enjoy the rest of the evening.